Hi kids, we'll be going with this paper discussion, and yeah, I have taken some questions wrong in the previous discussion, so I'll be covering up them in the end. Yeah, I think I'll be repeating this procedure again and again. If I am making any mistake here, I'll be rectifying it in the next discussion. Yeah, going for the first question. Two masses m1 1 kg and m2 2 kg are connected by a fine inelastic taut string shown. The m1 is raised vertically by height 20 meter and let it fall. So what is the time interval between m2 leaving the table and returning to it again? So what is happening? You are lifting it and you are dropping it. So it looks like this. So you are lifting it and you are dropping it. What will happen? It will start. It will gain kinetic energy. So just before the string becoming taut, so what will be its velocity? Root of 2gh, which will be 20. Now what will happen? Now this is just before becoming taut. Just after becoming taut, its speed has to become less. Now these two speeds have to become same because the string is inextensible. Now you can apply impulse equal to change in momentum, impulse equal to change in momentum, and or else you can see like you can see like horizontally how it behaves. Like if two masses are connected by a string and if you give velocity to first mass, so it will keep going, and after some time it will become taut, and you can say like both velocities will be same, or you will be using conservation of momentum. Though exactly conservation of momentum is not right thing here, but you can write impulse equal to change in momentum, impulse equal to change in momentum. From there you will be getting this velocity is 20 by 3, 20 by 3. It's like velocity is 20, total mass is 3, so 20 by 3. So I have written it directly, but if you want to see, you can write impulse equal to change in momentum. So what will happen now? This will go down with 20 by 3, this will go with 20 by 3 upwards. But what you know, this mass is heavier, this mass is lighter. So acceleration will be in this direction, right? This will try to go, this acceleration will be this way, this acceleration will be this way. So you can see velocity is in the upward direction, acceleration is in the downward direction. So what will happen? It will go up and it will stop at some point of time, and again it will come back, right? So what is that acceleration? You can draw FPD and you can find the acceleration. Acceleration will be 2g minus g by 3. Which is g by 3 in the downward direction for this one. For this one, g by 3 in the upward direction. So velocity is 20 by 3, acceleration is 10 by 3. So after what time it will be coming back? 2u by g, or you can use s equal to ut plus half at square, where s is 0, right? So you will be getting the answer as 4. Going to the next question. A short wave, speed of water waves depends on surface tension, density and wavelength. So you need to use dimension analysis. So how I will be doing it is, yeah, you have the traditional way, you can look into the solution, that's the traditional way, right? So surface tension is force per unit length, dimensions wise it is this much, lambda wavelength dimension wise it is this much, density dimension wise it is this much, velocity dimension wise it is this much. Now I am going to frame some equation. It's like what I have taken, I am trying to eliminate mass. Mass is in only two equations, so I am trying to eliminate mass. So what I can do, I can put this here and I am dividing with this, dividing with rho, right? So by doing this I am eliminating mass, Now t square is coming in the denominator here because of this. Now I want to eliminate t square also. How I can eliminate t square? Yeah, by inverting this and squaring it, Now when I look at this, the total dimension wise it is going to be L. So this is nothing but S, this is nothing but 1 by rho, this is nothing but 1 by v square, this is nothing but lambda. So from here I can get the relation. I mean, this is the quicker way of seeing it, but so it need not give you the right answer, or like you may not get the idea every time, but you can try it, right? Or we have the traditional method anyway, so that works for any question, right? So from here you will be getting this, from there you can eliminate, yeah, from there you will be getting the required answer, right? The next question, I think this question appeared in the previous exam. So for the circuit shown where the resistors are 3R, R, C and so initially when the switch is closed, the system is operating in steady state, voltmeter is ideal, and it measures VA minus VB. The switch is opened at t equal to 0. So just before opening the switch, how much is the potential difference? Just after, long time after, yeah, it is 0 at any moment and stuff. Okay, we'll see. So this is the initial question. So you are closing it and after steady state is achieved, this capacitor will behave like open circuit, this voltmeter is very large resistance, right? So I am opening it. So you can see this will behave like short circuit, and this current will be flowing this way, and that current you can find it as E by R, right? This question we have done in the last exam also. Now just after opening the circuit, what will happen? Flux through the circuit won't be changing suddenly. So this current and this current will be remaining same, and even I have shown like even the current reduces also, it will be flowing in this loop only. This current will be flowing in this loop only, right? Now anyway, so in the previous exam they asked what is the heat dissipated, and whatever energy stored in these two is dissipated here, whatever energy stored in this one is dissipated here. That's what we have done. But here they are asking what is the potential difference. What was the potential difference earlier? If this is 0, 0, E, 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 because no current is flowing, this will be E. So potential difference is, yeah, it measures VA minus VB, they said, right? It measures VA minus VB, they said. Yeah, so it is E minus 0 in the first case. Now in the second case, what is going to happen? I have taken this potential as 0 for reference. So this is higher potential and I into R. So this potential is going to be 3E, and this is higher potential and potential difference is E. I into R is E. So this potential is going to be 2E. So VA minus VB is going to be minus 2E. So option B is correct, option A is wrong. Now option C and D. So what does option C say? Option C says long after opening. Okay, after long time what will happen? No current will be flowing, right? Entire energy will be dissipated as it. So the potential difference is going to be 0. So option C is wrong. Is 0 at any moment? No, it's 0 only finally. So at any moment you can see it is not 0. So from there you can get the answer, right? Next one, a 20 centimeter long capillary tube is dipped in water. The water rises up to 8 centimeter. If the entire arrangement is put in a freely falling elevator, the length of the water column in the capillary tube. Now, you must have known the derivation. Either you must have done the derivation like this, or the easy way of seeing it is force balance, right? So when you draw FBD, you will realize like this pressure force and this pressure force will be getting cancelled. Whatever weight of the water column is there, that is being balanced by the surface tension force, right? But when in a freely falling elevator, now effective gravity or like weight will be providing that required acceleration, right? So there is no role of surface tension. Now if you want to see it much easily, you can observe from elevator frame. In elevator frame, so weight and pseudo force will be getting balanced. Now there is no need of surface tension force. The other way of saying it is, so when you are leaving it freely, the entire weight, the weight is the responsible thing which is trying to make it move in with acceleration due to gravity. So surface tension force must not come. If surface tension force must not come, what will happen? There won't be any meniscus, it will become flat. So surface tension force won't be there. So what will happen if surface tension force won't be there? It will be rising up to its maximum, right? Yeah, I mean if surface tension acts, then what will happen? It will be pulling it, and there is no one to oppose it kind of thing when you observe from elevator frame. So you can see that much easily from elevator frame. From elevator frame you can feel like effective gravity is 0. If effective gravity is 0, even if there is small amount of surface tension force, the water will be climbing up. But at the same time climbing up, there is no one to stop, so it will try to go out, right? But at the same time it won't be, while going out again surface tension will try to pull it back. So when you assume the damping thing, after some time it will be settling down, and obviously you know surface tension force must be 0 or else it will be having some acceleration. Surface tension force will become 0. So it will be climbing to its maximum, right? Largest and smallest distances of satellite from center of planet are given. At these two positions, V minimum, V maximum are given. So the time period of satellite A and B. Okay, so the first thing is this is the ellipse, and when the distance is minimum, speed will be maximum. When the distance is maximum, speed will be minimum. And you must have learnt in maths, right? So this length is called as A, and this length is AE. So this length is going to be A minus AE, and this length is A, this length is A. There will be one more focus here, right? By using that right angle triangle and Pythagoras theorem, we will be getting this length as root of this square plus this square, which is B. Now R max is what? This one, right? Which is A plus AE. R minimum is what? This one, which is A minus AE. Now how is A defined as? Now you don't have to do this entire thing, you know, like R max, R minimum. So summation of these two is 2A, and half of it will be A. So from there we will be getting option A. Now you need to see option B, right? So this I can write it as this way. Now what is this? This is R max, this is R min, right? Now I have written something here. What is this? Angular momentum at this. Angular momentum will be conserved because the force is always, angular momentum at this point is going to be conserved because force will always be passing through that point. So torque is 0 about this point. So angular momentum must be conserved. So what is angular momentum here? It is this much. Sorry, it is this much. What is angular momentum here? It is this much, right? So angular momentum conservation. I don't know why I have written it. Maybe I thought like it might be useful. Now they are asking some other thing. What is that other thing they are asking? They are asking V max into V minimum and the relation between time period, right? So I need to find V max into V minimum. So I have one thing, like either you can remember this result, or if you don't remember this result, then you can go with the derivation. So energy is conserved because there are no non-conservative forces. So energy, potential energy plus kinetic energy equals to E throughout wherever the particle is. But for these two particular points, I can write kinetic energy as angular momentum as mvr I can write. So kinetic energy I can write it as r I can write it as L by mv for those two particular points. So here I will be getting a quadratic in terms of v. So the solution of this quadratic will be giving us speeds at these two particular points. So but I don't need solution, I did only v1 and v2. So what is the product? In a quadratic product will be given by c by a, right? C by a. But what is the energy of ellipse? Energy of ellipse is going to be minus gmm by 2 times of semi major axis or major axis, right? So from there we will be getting gm by a, sorry, there have to be small m also, right? No, fine, v1 into v2 I calculated. So v1 into v2 is turning out to be gm by a. So what they are asking to calculate this t by 2 pi, 1 by 2 pi, okay. So t by 2 pi is going to be how much? Root of semi major axis cube by gm, right, which will be same as like circle stuff. Now root of v1 v2 is this much. So when you do that, you will be getting answer as a, right? Next one, two identical blocks are resting on supports as shown. Two identical bullets traveling with same speed hit the blocks, get embedded into them in a very short time. The block leaves the contact immediately after the bullet strikes. In case one, bullet's velocity is towards the center of mass, and in the second case it is off center of mass. So you need to calculate like which kinetic energy is more and what is the maximum height traveled by the center of mass. So this is the thing going to happen. If I assume, suppose for simplicity, if I assume both are equal masses, if the speed is v, so just after hitting, the total the combination speed will become v by 2 by momentum conservation. Though there is gravity, it is acting for a small time. Gravity is a finite force acting for a small time won't be changing the momentum of the system by a great extent. So we are neglecting the gravity during collision. Now what will happen here? Here also by momentum conservation I can say center of mass will be having a velocity v by 2. Now if I take torque about center of mass is going to be 0. If I am talking about only particularly this block, or you can consider angular momentum, right? So if you consider angular momentum about center of mass, initial angular momentum was 0, so final angular momentum will be 0. So there won't be any rotation thing. Now here you can see, if you observe only block, on block there is a push this way, right? If you observe only block, on the block the force is in this direction, so the block won't be rotating. But here the force is in this direction, so the block will be rotating. Now apart from this velocity, there will be angular velocity also. Now you can see translational kinetic energy is going to be same, but there is extra rotational kinetic energy. So this kinetic energy is more than this kinetic energy, but that has nothing to do with maximum height traveled by the center of mass. Now assuming that center of mass is at the same height, I think that's what they wanted us to assume. They didn't give any dimensions and stuff. So what you can say, kinetic energy, this translational kinetic energy will be converted as potential energy, but this rotational energy will still be there. No matter where it goes, that rotational energy will be there itself, right? Maybe that rotational energy also may change because of gravity will be passing through that point, right, center of mass. So rotational energy won't be changing, so it will be keeping on rotating, but it will be climbing up and again it will be coming back, but rotation effect won't be changed, it will be there. So kinetic energy is more in this case, but maximum height traveled is same in both the cases. An object of mass 2 kg is thrown vertically upwards in the presence of heavy air resistance. So the time of ascent is t1 and is no longer equal to time of descent, obviously. Similarly, the initial speed with which it is thrown is not equal to v, because initial speed you can't do energy conservation of mechanical energy you can't do, right, because friction is there, air resistance is there. Assume that air resistance is 10 Newton. So if air resistance is there, what can be the acceleration because of air resistance? Force is 10, mass is 2. So acceleration because of air resistance is going to be 5. Now while going up, what will happen? Acceleration due to gravity will be there, and apart from acceleration due to gravity, speed is in the upward direction, so air resistance will try to push it in the downward direction. So apart from acceleration due to gravity, there is air resistance, so both are in the same direction. But while it is coming down, what will happen? Acceleration due to gravity will be in the downward direction, but air resistance will try to provide the force in the upward direction. So while going up, acceleration is 10 plus 5, while coming down, acceleration is 10 minus 5, which is 5, right? So if I plot VT graph, it looks like this. While initial velocity is in the upward direction, so positive. So while going up, what is the acceleration? Acceleration is in the downward direction, right, which is g plus a, and I mean slope, but I just put like for reference. Now after this, velocity will become 0, right? Now velocity will be in the increasing in the downward direction. Now what is the acceleration? Now the acceleration is going to be g minus a, which is 5, right? Now if it is reaching back, then this area and this area must be same in magnitude, right? Now this is the initial velocity with which you are throwing. This is the final velocity what you will be receiving, right? Now area under the graph must be same, so I have put this. From there I will be getting option B is correct, option A is wrong. But again, this velocity I can write it as g plus a into t1, right? Yeah, you can by using slope equals to acceleration, right? Slope of VT graph will give you acceleration. So from there I can say this velocity is going to be g plus a into t1. So this I can write it as half g plus a into t1 square. This I can write it as half into g minus a into t2 square. So from there I will be getting the required answer, right? Option D. The next one, a radioactive nucleus can decay in P or Q with decay constant 2 lambda and lambda respectively. Another radioactive nucleus B decays in Q with decay constant 3 lambda. Initially number of active nuclei of A and B are equal, so you need to find what is the correct relation. So what they said, this is the thing, A can decay into P and Q, B can decay into Q. These constants are 2 lambda, lambda and 3 lambda. So I can say the rate at which P is generating is 2 lambda times of Na. The rate at which Q is generating is lambda times of Na plus 3 lambda times of Nb. But what you can see, A is disintegrating at 2 lambda and lambda. So this is the rate at which it is disintegrating into P. This is the rate at which it is disintegrating into Q. So the rate at which it is disintegrating equals to summation of that, right? So from there you can see it will be of this equation, this general solution, you know, it will be of this form. So number of nuclei of A after any time will be given by n naught into e power minus 3 lambda t. Now similarly you can do for B, and this B value also you will be getting. Now what they are asking? They are asking Na equal to Nb. So option A, Na and Nb are equal, right? Yeah, at any time. So option A is correct. Thereafter you need to find the relation between Np and Nq, right? So you need to find Np and Nq. So Np, you need to find P, right? How you will be finding P? It is integration of 2 lambda Na dt, right? So but Na you know, so when you integrate it, when you substitute the limits, you will be getting this much. Np is this much. So similarly Q you can write, right? Na you can substitute, Nb you can substitute, Na and Nb you got, so you can substitute it back and you can integrate it and you will be getting this result. From there you will be getting option D as correct, remaining options as wrong. In the circuit shown, capacitor was initially uncharged, switch is closed, so you need to select the correct alternatives. When the switch is closed, initially what will happen? This capacitor will act like short circuit, right? It will be getting charged, it will act like short circuit. So if it acts like short circuit, then you can see like the potential difference across this one is going to be 0 at that moment and no current will be flowing through this. So I just removed it and it will act like short circuit. So if you want to find the current, you can find 48 by 1.2 mega, right, which is going to be 40 micro. So from there you will be getting option A as correct. Now going to option B, the battery current after long time what will happen? Capacitor will get fully charged and will behave like open circuit. When it behaves like open circuit, current will flow this way, right? So then the circuit will look like this, then you will be getting the current. That also you can manage. The time after which current through the capacitor becomes half, or the next one is the current through 600 kilo ohm as a function of time. So for that what I am going to do is, I am going to find the properties across the capacitor. So for that what I can do, I am using Thevenin's theorem. You can refer current electricity revision video if you don't know how Thevenin's theorem work. So if I convert into Thevenin's theorem, like I will be getting Thevenin's voltage is 16 volt and Thevenin's resistance is this much. So this is a simple circuit. We know the general solution will be of this form. At t equal to 0, charge is 0. After a long time, charge is going to be Q equal to CV, right? C into V. C into V is going to be 40 micro, right? So from there I will be getting A value, B value. So when I substitute it, and time constant, what is the time constant? R into C. So time constant for this circuit is going to be 1 second. So option C you can manage now. The time after which current through the capacitor becomes half. Current through the capacitor becomes half is like after half time, right? So it is half and logarithm is not coming into picture, so you can eliminate option C. Now what I did, finally I got the charge in the capacitor. Once I get the charge in the capacitor, I will be going back to the circuit. So I know the charge across the capacitor, so what I can do, I can find the potential difference across the capacitor. If I know the potential difference across the capacitor at any time, that is going to be the potential difference across the resistance also. Then I will be dividing with the resistance. So I know charge, so from there I will be finding the potential difference across the capacitor, which will be same as potential difference across the resistor. So I can equate that potential to I into R. From there I will be getting current in 600 kilo ohm, right? Okay, the next question says, if one of the slit of standard YDSC is covered with thin slab so that it allows 1/2 of the light intensity, then what will happen to the resultant intensity? So I maximum will become, yeah, you know I maximum formula, I minimum formula, and what they said earlier, they used it to be equal, but now now they will become unequal, right? So but again, yeah, let me say this is becoming less. If this, okay, let me say this is becoming less. If this is becoming less, what will happen? Initially both are equal, but now if this becomes less, the overall value will become less. So bright fringe will become less bright. But what will happen here? Earlier it was 0, but if this reduces, now it is not going to be 0. So brightness of dark fringe will increase, right? So A and B are correct. Now fringe width doesn't depend on the thickness of the slit. I didn't do it, but I think that's one of the things which will be taught in the class generally. Fringe pattern will shift towards the covered slit. That also you can manage, right? If the slab is on the first slit, then central bright fringe will be shifting upwards, right, which is towards the slit which is covered with slab, right? Okay, next question. Consider the following circuit and you need to find the currents. What I have done here is, okay, I'll mark like, anyway, I am not going to do this way, but this I have done just because I have to give some solution. So I have taken this as 0, so this reference is going to be 0, then that is going to be 2, then this is going to be 2. Now I can't take this as 0 because I have already assumed this potential is going to be 0, right? So I am assuming this as x. If this is x, then this is x plus 2, this is x plus 2. So, and I don't know this, so I assumed this as y, this as z. So thereafter I calculated the current in this using potential difference by resistance, and I calculated current in this, and I calculated current in this, current in this, current in this, current in this, current in this. Thereafter I used KCL at this point, and I said the current in this one is going to be this much, and I used KCL at this point and I got the current is this much. Similarly, I used KCL at this point, I got the current as this much. I used KCL at this point, I got the current as this much. Now this current and this current, like, right? So if I take any point, so this is incoming current, this is incoming current, so outgoing current is 0, so summation of this plus this must be 0. Similarly here, this is outgoing current, this is outgoing current, so incoming current is 0, so this plus this must be 0. I have used this plus this current is 0, this plus this is 0, and apart from that I used KCL here, this current plus this current equal to this current, and I have used KCL here also, this current equals to this current plus this current. So I got 4 equations, but I don't need 4 equations because only 3 variables are there, right? I can use any 3 equations. So that's the same thing I did. I used 3 equations and I solved them. I got x equal to 0, y equal to 1 and z equal to 1. When I substitute the values, I can see no current will be flowing through this one, no current will be flowing through this one, no current will be flowing through this one. So then you can see current will flow only like this, current will flow only like this. So it has nothing much to do. That I could have predicted also, because if I take the, suppose if I assume the circuit is going to be like this initially, then if this potential is 0, I can easily show like whatever current battery will be giving, it must be receiving back. So the current will be flowing only in this, current will be only flowing in this. So if I assume this potential is 0, this will also be 0. This will also be 0 because no current is flowing through this, right? So then when I calculate this potential, it is going to be 1. I can calculate the current, I can find the potential. Similarly, if I calculate current and potential, it is going to be 1 here. Now if I put one resistor here, what will happen? No current will flow because potential difference is 0. So I am going to put 4 ohm. Now I am going to put one more 4 ohm here. In that also no current will flow, which will effectively be the question asked, right? But yeah, sometimes it's hard to see, so it's always better to have traditional method. When an impedance consisting of inductance and resistance in series is connected to one 12 volt 50 Hz supply, a current of 0.05 ampere flows, which differs in phase that from applied potential difference by 60 degrees. If the capacitor of capacitance is connected, then current is in phase with potential difference, so it is becoming resonance. So initially they said resistor and inductor are there. I didn't draw the figure, but you know, if the current, if I take current as reference, then voltage across the resistor will be in phase, voltage across the inductor will be leading by 90 degrees, resultant will be given by this much, which is I into root of r square plus xl square. Now they said it is making an angle 60 degrees. From there, when I take tan theta, I can say xl equals to root 3 into r. Now apart from that, in the next case what they are saying, I think, yeah, okay, in this case only they are saying like current is 0.05, right? So how you will be finding the current? E equals to I into z. Now how you will be finding z? Root of r square plus xl square. xl is root 3 r. So when you substitute, you will be getting z value as 2r. Z value as 2r. So from there, you know the values of ER and IR. These are RMS values, right? So you will be getting the resistance value as 120. So till there we have used the first case information. Now they are saying it will be under resonance when you add the capacitor, right? So anyway, I am going to calculate inductance value. So 2 pi f into L, omega into L. Omega into L is, R is this much, so XL equals to root 3 into R. So XL equals to root 3 into R. From there I will be calculating the value of L. So from the first information I can calculate till here, but they are asking the capacitance value, what needs to be connected so that it will be under resonance. So resonance condition is this one, right? When that's the natural frequency of the circuit. So when the source frequency matches with the natural frequency, angular frequency, then what will happen? It will be under resonance. From here C value will be 1 by omega square into L. Omega square is 2 pi f square, and L value you can substitute it back and you will be getting the answer, right? Okay, the next question, in the given arrangement, both blocks of same mass 2 kg, initially spring is compressed and the compression is 10 centimeter. The spring constant is 200 Newton per meter. What is the ratio of relative accelerations and acceleration of center of mass of the blocks? So when you draw the forces along this direction, gravity component mg sin theta, which is 1g, and apart from that spring force is 20, spring force is 20. Right, so what is this acceleration? F equal to ma, you can use this acceleration is going to be 5 upwards, this acceleration is going to be 15 downwards. So relative acceleration will be 20. Relative acceleration will be 20, right? 15 plus 5 by what is the acceleration of center of mass? Spring force is internal force, the only force is gravity. So gravity's component will be providing acceleration how much? G sin theta, which is g by 2. I have taken it directly. So from there you will be getting the required answer. Next one, in the given circuit, you need to find what is the magnetic field at this point. That's a straightforward question. Either you can calculate the field because of this wire separately, right? I have written everything here. I think that's a straightforward question. You can manage. Field because of this wire is going to be this much, this wire this much, this wire this much, this wire this much. All right. I have put everything here. So or else, yeah, when you see that when you add them, you will be getting the required answer. That's not a big thing, but or you could have done this also. You could have seen like field because of this one is going to cancel because of field because of this one. Field because of this one is going to cancel because of field because of this one. So effectively, you need to calculate field because of only these 4 things. Or I can say like due to this one, it is going to be into, this is going to be out. So I can say these two effectively it will behave like a I in this direction, right? Similarly, I can do the same thing. Whatever it is, you can manage. Next question, a tuning fork and a string of length give 4 beats. The string is made shorter without any change in the tension until it is in unison with the fork. Its new length is 99 centimeter. The frequency of the fork is how much? So yeah, whenever things are becoming difficult, like we'll be assuming like it is fundamental, right? So when it is under fundamental, anyway, V equals to lambda f. Now when it is under fundamental, lambda by 2 equals to L. So lambda equals to 2L. 2 has to come in the denominator. 2 has to come in the denominator. Lambda equals to 2L. When you substitute it, you will be getting frequency as V by 2L. Anyway, frequencies V is not changing because tension is not changing this side. So frequency is inversely proportional to the length. When you are reducing the length, what will happen? Frequency will increase. From there, what you can predict? You can predict initially tuning fork has more frequency. So it gives 4 bits, they said, right? So let me say initially the string is vibrating with certain frequency and tuning fork is having higher frequency. Now what is happening? You are reducing the length. When you reduce the length and when you start vibrating it, what will happen? Its frequency will increase. That's what we understood. The natural frequency is inversely proportional to the length. So what will happen? When you are reducing the length, the frequency will increase and they will become common, right? So from that information you can see this is more than this. tuning fork frequency is more than fundamental of the first case, right? So you can see when you take the ratio initially, yeah, if the tuning fork frequency is f, then what is the frequency of the string in the initial case? F minus 4. F minus 4 is inversely proportional to 100 and f is inversely proportional to 99, right? So from there you will be getting the required answer. The heater is designed to operate with a power of 100 watt in 100 volt line. It is connected in combination with the resistance and stuff. So now when the heater is operating at 62.5, what should be the value of R placed, right? And AC or DC doesn't matter here because all are resisted, so it works the same way, right? So I just have taken DC as example. Now from the initial given information like 1000 watt and 100 volt, when it is rated 1000 watt across 100 volt, from there you can predict you can get the resistance value as 10 ohm. Now they said the power in this one is 62.5 and the resistance you know, so you can calculate the current. Current is going to be 2.5. If the current is 2.5, potential difference is 25, so this current is going to be 25 by R. Now if the current is 2.5, 25 by R, then this current is going to be 2.5 plus 25 by R. Now I use it V equals to IR, where R is the equivalent of this thing. So V equals to I into R. R is 10 plus 10R by 10 plus R, right? So from there when I solve, I will be getting the required answer as 5. So the next question, a large tank is filled with water at a constant rate. There is a hole punched at the bottom. So find the maximum height that can be filled, right? So initially it is empty. So when you start pouring water, what will happen? It will start leaking. But that leaking velocity will be dependent on the water height, right? So when the water height is less, the leaking velocity will be less. So I can say like incoming water is more than outgoing water. So what will happen? The water level will start increasing. But you know, when the water level starts increasing, this speed will start increasing. So if this speed starts increasing, the water outflow rate will increase. So initially water inflow rate is this much, but water outflow rate is 0 almost. But with the height level, what will happen? Outflow rate will start increasing. At certain point of time, they will become equal. So inflow rate is equals to outflow rate. After that, what will happen? Whatever water you are pouring, it will be going here and it will be attaining a fixed height, right? So inflow is equals to outflow, A into V. V will be given by root of 2GH, right? So inflow equals to outflow. From there, you will be getting the required answer, right? So the next one, a cardboard strip bent in the shape of letter C is put on rough inclined plane. If alpha is the maximum angle for which the block doesn't topple, find the value of 90 alpha square. So whenever they say about toppling, what you will be doing, you will be drawing the figure and you will be seeing the critical condition, right? That is, the normal will keep shifting. Just before toppling, the normal will be like along this axis, right? Now if I calculate the torque due to weight, mg sin theta, mg cos theta will be there. I just have resolved so that it will be easy for me. Mg cos theta won't be creating any torque. Mg sin theta, what will be the torque because of mg sin theta? L by 2 into mg sin theta. Now torque because of this weight, this part, it's mg cos theta, it will be providing some torque. Mg sin theta also will be providing some torque. Mg sin theta will be trying to rotate it this way, but mg cos theta is trying to rotate it this way. So how many, this mg sin theta, this mg sin theta, this mg, all the 3 mg sin thetas will be trying to rotate it this way. So L by 2 into mg sin theta for this one. So L by 2 into mg sin theta for this one, but it is 2 times, right? This one and this one, I combined it. Now that will be balanced by the torque because of mg cos theta of this one, which is L by 2 into mg cos theta, L by 2 into mg cos theta. So from there you will be getting required answer, right? Okay, we will be going to the second paper. The second paper, a horizontal disc of radius, this is fixed, 1.5 mass left string is fixed to the and okay, you can read the questions now. So you are giving a velocity, perpendicular to the string. So what is going to happen? What is going to happen? Tension will always be perpendicular to velocity, so it won't be changing any kinetic energy. So from there you can see option D is correct because tension will always be perpendicular to the velocity, it won't be changing the kinetic energy. But what about angular momentum? You can see, like, if I am talking about angular momentum of this particle about this point, angular momentum is there in this direction. So if you want to calculate angular momentum, you need to see like r bar cross mv bar. Anyway, but there is tension force, right? Tension force, and that is creating some torque, right? You can see the tension is applied in this direction, right, on this particle. So that is trying to create torque in the opposite direction. Angular momentum is in this direction, torque is in the opposite direction. So what will happen? Its angular momentum will reduce with time. Now in later moment when I draw the figure, it looks like this. It looks like this. The string must have covered here and some part of it must have gone here. So if it is covering angle theta, then this length is going to be r theta. So out of this length L, r theta is being covered here. So remaining length is L minus r theta. Now you can see if this is covering angle theta, this also will be angle theta. That's quite easy to see. So now what is the rate at which this angle is rotating? That is omega. Omega is v perpendicular by this length, right? D theta by dt equals to v perpendicular by this length. So now what you need to see? You need to see after how much time it will be fully covering it up, right? So the variables are theta and t. So I am bringing one variable to one side, other variable to other side. Now I need to put the limits. While for putting the limits, what I need to see? I need to see what is this length. So if this length is 2 pi r, then it will be covering an angle 2 pi, right? If this length is 4 pi r, it will be covering 4 pi, right? Now for that what I need to see? I need to see the ratio of L by R. L by R ratio is going to be 4. The meaning is it will be covering 4 radians. It will be covering 4 radians. 4 radians will be something like this, right? Yeah. So it will be covering 4 radians. So when you integrate it, when you substitute the values, you will be getting the answer as 4. Now have all the options addressed. Object will hit at 4 seconds, we concluded. Angular momentum is not remaining constant about O, it is decreasing. Kinetic energy will remain same. Okay. So the next question is, an object is placed at OP equals to U. So for the given options, you need to find like which is correct, right? So for refraction at curved surface, this is the formula you must be knowing. Now in the first case, they said when mu1 is greater than mu2. When mu1 is greater than mu2, from here I will be writing mu2 by v equals to this much. Now u is negative in the question. U is negative in the question. That's what they wanted to ask, though they are saying like for every u. So you need to go with the figure. U is always negative in the given figure. So if u is negative, then this value will turn out to be negative. This value, according to the given information, r value is positive. According to the given information, incident ray is going this way. So this is positive direction, this is negative direction. Radius of curvature will be that side, so r will be positive, but object distance is negative. So r is positive, but this total term mu2 minus mu1 is going to be negative, right? So this is negative, this is negative, so this term will be negative, v is negative. What does it mean by v is negative? Image will be forming on this side. If image is forming on this side, the meaning is rays are not actually meeting. Rays will be going into other medium, right? So if they are meeting, they have to meet only that side. So if they are meeting this side, the meaning is they are imaginarily meeting, which is going to be virtual image. Now if mu2 equal to 2 mu1, when I substitute it back here, mu2 equal to 2 mu1, I will be getting mu1 by r. Now u is negative, r is positive, so I don't know what is about this value. If mu2 equal to 2 mu1, then image is virtual for r greater than u. So virtual in the sense v is negative, right? So let me see for what value v is negative. If this is negative, this term has to be negative, right? So mu1, when I remove it, so I am putting like u value is negative of its modulus, r value is positive of its modulus, and this term has to be negative. That's what they are saying. When it will be negative? When r is greater than u. So option B is correct. If option A is correct, option C is going to be wrong. Now option D, if n2 is greater than m1, the image is always real. So if n2 is greater than n1, then this is going to be positive, this is going to be negative. Now if it has to be real, it has to be positive. So we need to see when this will be positive. It's not for all values, there will be some particular relation, right? So from there D is going to be wrong. Wavelength and intensity of monochromatic light falling on light cell is given and stuff. The threshold wavelength of the metal is 3700, and yeah, anyway, that you can manage. So Hc by lambda, when lambda is an angstrom unit, so you will be getting 3.35 electron volt, which is option A. Now the other wavelengths, wavelength at t equal to 0, t equal to 5, t equal to 20, when you see, they will turn out to be this much. Now this is the minimum, this is the threshold wavelength, right? So if the wavelength is less than this, what will happen? The electrons will be coming out. So what is the only one which is less? This one, right? So here current won't be 0, but in these two cases current will be 0, right? Which among the following forces are conservative? So you people must be doing this in the class, right? The curl will be 0 is the easiest way to do it. So you will be putting the modulus, and this is called curl, right? So when you take the modulus, what you will be doing? Yeah, first one you will be taking this into this, which is going to be 0. Differentiation of 0 is 0. Differentiation of x square is 0, because you will be taking remaining things as constant other than z. So this is going to be 0 minus 0. Now similarly, when you take this one, differentiation of 0 is 0, differentiation of 2xy is 0 because z is the only variable. Now in the third case, this into differentiation of this is 2x, and differentiation of this with respect to y, 2x is constant, differentiation of y is 1, so differentiation of this one is going to be 2x, so it is going to be 0. If it goes as 0, then it is conservative. If it goes as non-zero, it is non-conservative, conservative, non-conservative, right? There is time varying magnetic field and it is increasing with time. If magnetic field is increasing with time, then there will be induced EMF which will be electric field will be in this direction, right? So EMF will be, if I voltmeter resistance will be very large, right? So if I neglect the current flowing in this one, I can see like there will be a induced EMF like this, right? If I talk about only this particular path. And what is the reason? It is induced electric field. Now if the current is flowing this way, so I can say like E equals to IR, induced EMF, how I can find? dB by dt into pi a square, right? Pi r, dB by dt into a. So dB by dt is given as B naught, so this is the induced EMF. From there option 1 is correct. If you want to find the current, induced EMF by the resistance, that is going to be the current. Now there will be a very small current flowing through the voltmeter which we neglected earlier. Now if I take this loop alone, there is no change in flux through this one, so the net EMF in this one has to be 0, right? So I into R plus I into R must be 0, right? So or else this potential difference and this potential difference must be same, I can say. So I into R1, that will be I1 into V1, I mean resistance of V1. So voltmeter will be reading current through it into resistance of it, right? That will be magnitude wise equal to I into R1. Now this voltmeter will be reading current through this one into resistance of this one, which will be magnitude wise equal to this current into this resistance. Current we know into resistance, current we know into resistance. So from there option B is correct, option C is wrong. If option C is wrong, obviously option D will be wrong. Consider a uniformly charged conducting uniform spherical shell of radius r. Net charge on the shell is capital Q. There is a small hole in the shell at A. A point charge minus Q is released from a distance 2r from the center. The important thing in the question is both have same mass. Now they are asking what is the distance traveled by point charge till it hits and stuff. So what will happen? Oh sorry, I have done it wrong. Sorry. This is not 3r by 2. Leave it. This is not correct. So center of mass of this one is here. Center of mass of this one here is here. So the total center of mass is going to be here, right? The total center of mass is going to be here. So total center of mass is, anyway, that's, I think that's correct only. So let me look at the question. So they are saying like when they are hitting, how much distance, whatever distance, see both masses are equal, that is going to be much easier thing, right? Because whatever distance this moves, this will also move by the same distance, right? Now what is the total distance between them initially? It is 3r. So if they are going to hit, the meaning is this the total distance between them must be reduced by 3r, right? So the meaning is this has to cover 3r by 2. This is not center of mass, so this has to cover 3r by 2 and this has to cover 3r by 2, then this will be hitting here, right? Total distance is 3r, so both will be moving equally, so it has to move 3r by 2 to hit it. So option A is wrong, they said, which is 5r by 2. Now apart from that, what is the speed with which it will hit, right? That's the question, right? The speed when it hit the shell. Now the important thing is only till it is outside it will be accelerating. Once it goes into the shell, it will move with a constant velocity because force inside the shell is going to be 0. So what I did here is I did energy conservation till it is just entering the shell. So if it is entering the shell, this momentum and this momentum has to be equal because initial momentum is 0, final momentum has to be 0. So this momentum and this momentum must be equal, and as the masses are same, this kinetic energy and this kinetic energy must be same. So initial potential energy plus initial kinetic energy, this one is 0, this one is 0, equals to final potential energy here plus kinetic energy of this one plus this one, right? So from there you will be getting what is the speed of the particle, right? Now they are asking what is the time taken to hit from here to here. So when it is going, now what happens once it goes into the shell, it will be moving with a constant velocity this much, right? This will have velocity v and this will have velocity v. What is the relative velocity? 2v. And what is the relative distance that has to be covered? 2r. So time taken will be 2r by 2v. V you can substitute, you will be getting the answer which doesn't match with option C. A cylinder of mass m and radius r lies on the plank. The surface between a plank and ground is smooth and this surface is rough. Assume no slipping and velocity amplitude of oscillation of the plank is v. So what is the maximum velocity of the plank? It is v, they said. So how the figure looks like at mean position? At mean position, this velocity will be maximum. Let me say v. Now let me say this velocity is this v and its angular velocity is omega. Now by pure rolling condition, v plus r omega, this v plus this r omega must be equal to this v, right? Now if I write the force equation at any instant, then there will be spring force k into x. Yeah, let me say I have pulled it this way. Now it is going to accelerate this way. So kx minus f, right? Now this is the friction which must be pulling it forward, right? Now I can write equations, kx minus f equals to this mass times of this acceleration. Kx minus f equals to this mass times of acceleration. Now this f equals to this mass times of acceleration, which I am calling it as this a. This is the acceleration of plank, this is the acceleration of the disc. It is disc only, right? Yeah, disc. Now apart from that, I can write torque equals to I alpha for this one. What is the torque? F into r. Torque equals to I alpha. But what is the constraint relation? Pure rolling, pure rolling. So the meaning is this acceleration will be equal to this acceleration plus r alpha. This is the constraint relation, right? Constraint relation. Now from here I can see this a equals to r alpha by 2. So from there I can predict v will be equals to r omega, right? Yeah, integral dt, you can do that. And I can predict the relations also. I can just substitute it back and I can say like this acceleration is going to be a by 3, this r alpha is going to be 2a by 3, everything. Now why I am doing this is so that I can substitute it easily here. Now if I add these two equations, I will begin kx equals to m into this acceleration plus m into this acceleration, but this acceleration is a by 3. So ma plus ma by 3 will be 4ma by 3. From there I can see it is of SHM form, so time period is going to be this much. Now this maximum kinetic energy is going to convert as potential energy, right? So that I can find the amplitude. That kinetic energy is being converted as potential energy. Kinetic energy of the plank plus translational kinetic energy of the disc plus rotational kinetic energy of the disc will be converted as potential energy in the spring. And this velocity, I can see this velocity and this velocity, how they are related. They will be related like this acceleration, right? So this velocity is going to be v by 3, this velocity by 3. And r omega, how r omega is related? It is related as 2v by 3. So 2v by 3 whole square will be 4v by 9 square, 4v square by 9. So you can see single variable. From there you will be getting amplitude as this much, amplitude as this much. Now at that amplitude, what is going to be the acceleration? At that amplitude, acceleration of the plank is going to be this much. If acceleration of the plank is this much, acceleration of the disc is going to be this much. If acceleration of the disc is going to be this much, from there I can predict what is the friction, right? The next question, a rod of mass m and length L is acted upon two forces as shown. So you need to find what is the stress at the midpoint and at a distance L by 4 and the net change in the length and total elastic potential energy. So initially I will be writing F equal to ma, so net force equal to mass times of acceleration. From there I will be getting acceleration as this much. Now if they are asking what is the stress at the midpoint, you need to see what is the restoring force at the midpoint, right? So you need to see what is the tension at the midpoint, tension like tension or compressive force, whatever it is. So if I write F equal to ma for this half rod, what I will be getting? Ft plus F equals to half the mass into acceleration. So from there we will be getting tension at the midpoint is going to be 0. So which says option A has to be 0, but it is not 0, so it is wrong. Now at a distance L by 4. So if you take whether this L by 4 or this L by 4, this L by 4 or this L by 4, and I assumed the tension is going to be pulling and this one is pushing, this compressive and this is tensile force, I assumed. But when I calculated net force equals to mass times of acceleration, mass is m by 4, only 1/4, right? I got it as minus f by 2. The meaning is my assumption is wrong. This force is going to be this way, this force is going to be this. So this is going to be compressive, this is going to be tensile. So when I put it in the right figure, this figure looks like this when I put it correctly. F by 2, F by 2. Now you can see the same thing is going to happen again. So this tensile force is equal to this compressive force. Now here compressive force will be equal to here tensile force, right? So you can see whatever compression is happening at this point, it will be balanced by this extension. So whatever extension happening in this half will be balanced by whatever compression is happening in this half. So net is going to be 0. Net change in the length of the rod is going to be 0, but net change in the length of the rod doesn't mean potential energy is 0, because you can see there will be a extension here, so there will be energy stored here, energy stored here, energy stored here, and after this half there will be compression, so energy stored, right? So it is not 0. Consider the system shown. Yeah, I think you can read the question. What they are saying, they are giving the velocity like this. For what minimum velocity this will come up, right? If it is just about to come up at the critical condition, yeah, so tension will be equal to mg sin theta, right? And it will be performing circular motion, right? So T minus this weight equals to mv square by r, but T is this mg sin theta. T minus mg equals to mv square by r. From there, when I substitute the values, I will be getting the required answer. Next one, yeah, there is a horizontal wall like this, yeah, and disc is placed here, and you are sending some light beam. So because of that, what is going to happen? The beam is going to push it upwards. It is more than weight, so it is going to push it this way. Because of that, normal will be acting downwards. Now that beam force is not only in the vertical upward direction, it will have components. One component in the upward direction, one component in the horizontal direction. Now this component will try to push it this way, but friction between the disc and the wall is trying to apply opposite force, right? By definition, intensity is the energy passing through perpendicular area in unit time, right? So from there I will be finding what is the force on this area, because this is the area perpendicular, right? What is, if this area is A, this area is going to be A cos theta, right? So what is going to be the force applied? The force applied is going to be I by C into A cos theta in this direction. But when you take the components, it is going to be this component cos theta and this component sin theta. So this component is going to be this much, right? But weight is there downwards and it is pushing upwards, so normal is in the downward direction and it is trying to push it in the forward direction, so friction is going to be in the backward direction, right? So when you write balance force, you will be getting normal from here, and under the critical condition these two must be equal, right? Or if this force must be greater than this force, that's what I have written. But this force is mu into n, but how you will calculate n is this minus mg, right? So from there you will be getting the required answer, right? A tunnel is dug inside earth across the diameters. Radius of the earth is r and mass is m. A particle is projected with some speed. So what is the velocity at the subsequent motion? I didn't draw the figure, but you know its energy conservation. Potential energy at the surface and kinetic energy at the surface equals to potential energy at the center plus kinetic energy at the center. So from there you will be getting the required answer, and you can see it will be escaping to infinity because the total energy is going to be 0. In a hypothetical atom, negatively charged particle is charged and stuff. Oh yeah, you can see that. So we will be going with Bohr's model derivation. So if Q is the charge of the nucleus and Q is the charge of the electron, then electrostatic force will give us the required centripetal force, and mvr equal to nh by 2 pi, angular momentum conservation, right? So from here I am trying to calculate the velocity. If I calculate the velocity, I will be getting the kinetic energy. If I get the kinetic energy, I know like total energy will be, sorry, this has to be E. It is not U. Total energy will be like almost similar to kinetic energy if I want to talk about proportionality, right? Magnitude wise it is negative of kinetic energy, right? So but kinetic energy is dependent on mass of the electron and charge square of the electron, right? So what difference it makes from hydrogen to this? Mass is becoming 3 times and charge is becoming 3 times. So totally energy will become 27 times of whatever is happening in hydrogen atom, right? Hydrogen atom energy of energy of that orbit is going to be minus E naught, they said, right? So in this case it is going to be minus 27 E naught. So generally we used to write 13.6 into 1 by 1 square minus 1 by 3 square if it is hydrogen, but in this particular case instead of E naught it is going to be 27, right? 27 into 13.6, 1 by 1 square minus 1 by 3 square. So from there you will be getting h by lambda, which is momentum, right? The next question, there is a current carrying wire 60 ampere. So you need to find integral b bar dot dl bar for a circle x square plus z square equals to 3r square. So if a current is flowing this way, actually we can apply Ampere's law for only steady currents. Now how can steady current be possible here? There must be some other thing available, right? So the easy way of predicting it is like, let me say there is some charge plus q here, there is some charge minus q here, so current will be flowing via this wire. Now when current is flowing, what will happen? This charge will reduce. If this charge is reducing, the flux through this one is going to reduce. Now if there is a charge q, what is the flux through this one? Q by 2 epsilon naught into 1 minus cos of this angle, that angle is 60. So flux because of this one is q by 2 epsilon naught into 1 minus cos 60, flux because of this one is q by 2 epsilon naught into 1 minus cos 60, both will be in the same direction. So it is going to be, total flux is going to be this much. Now the rate of change of flux will be given by this much, dq by dt is minus I, right, because this is reducing, right. So from there I will be getting epsilon naught d phi by dt as this much, but this term is called as displacement current, right, displacement current. So if you are applying Ampere's law, you need to take care of the displacement current also. So when I put that, I will be getting mu naught I by 2, mu naught I by 2. So actual current and displacement current. Actual current is going this way, displacement current is going this way. So the net current is going to be I by 2. I think this is the right way I see. I don't think what they have done is right, but you can look into the solution also, that's fine. There is an inclined plane and it is rotated and stuff. Yeah, that's. So it is performing circular motion, right? So how many forces will be there? Mg, normal and friction. Now net force along horizontal must be providing the required centripetal force. Normal's component minus friction's component will be providing required centripetal force, and normal's component plus friction's component must be balancing the weight. When you solve it, you will be getting the required answer. 4 point sources are there and given conditions, so you need to see like how many frequencies will be heard, right. So in the first case it is moving in this direction, in this case this will be, yeah, this will be hearing more frequency than the actual. These two will be hearing the same frequency, I mean that's actual frequency. This will be hearing the less frequency, so 1, 2 and these two will be hearing the same, so 3. So in this case it will be hearing 3 different frequencies. In the next case these two will be hearing the same frequencies which is more than the natural. These two will be hearing the same frequencies but which will be less than, because source is going away, right, along the line joining. Source is going away along the line joining. For this one source is coming towards, for this one source is coming towards. So the next one, it is going this way. So along the line joining, it is going perpendicular to the line joining. So all 4 will be hearing the same frequency which is the actual frequency. In the next case, along the line joining it is coming towards, so this will be hearing more frequency. This will also be hearing the more frequency. This will be hearing less frequency, and this will be hearing less frequency. So these two will be hearing more frequency and it will be same in magnitude. These two will be hearing less frequency which will be same in magnitude, because the values of the velocities are 5. You can get that, right. The next question is going, yeah, next question they have given some information like this and stuff. They are asking molar heat capacity, and in which case it will be happening this way. So when you bring this P delta V this side, you will be getting delta Q equal to delta U plus P delta V, that is work done is P delta V. When will work done be P delta V? Only when the pressure is constant, right. PdV integral will become P delta V only when the pressure is constant. So they are asking which thing is constant pressure, and molar heat capacity is negative in which one. Now before that you must be aware of this polytropic process. PV power x is constant in so C value will be given by r by gamma minus 1 plus minus r by x minus 1. Now bulk modulus is given as this much. This formula you will be knowing, yeah, coefficient of volume expansion and stuff, PV equal to nRT. You can write PV equal to nRT this way also. Now in the first case they have said this is constant. I will be converting into PV power x, so that I can use the formula for that polytropic process whatever I have derived. So T I can replace with P into V by nR, right. Anyway, I need only constant thing, proportionality thing, so I am calling it some other constant. So from there when you do, you will be getting PV power 7 by 5 is constant, and they said it is diatomic gas, so this is gamma, so it is going to be adiabatic process. Similarly in the second case when you do that, PV power 3 by 2 you will be getting, now this is PV power x, so CV minus R by x minus 1. So molar heat capacity is negative. Similarly, if you do for the next one, isobaric process, so isobaric process will be giving answer for the 36th question, right? The next one. Now molar heat capacity, yeah, it is not going to, in isobaric you know molar heat capacity, right? It is positive. So PV power minus 1, again CV minus R by X minus 1, minus 1 minus 1, which is going to be positive value. Molar heat capacity is positive. So molar heat capacity is negative here, and isobaric process is this one. If you want to check the remaining options, you can try by yourself, right? Yes, and going to the patchwork of the previous paper. So this question, I have made a mistake in these angles. I have written here like theta equals to 60, but it is going to be 30. So this theta is going to be 30, 30, 30, 30. So from there I can get, this is 60 and 60, 60 and 60, 30 and 30, and I can see this triangle is similar to this triangle. From there I will get, if this length is 10, this length is 10. So similarly, if this length is 10, this length is 10, then this is going to be 20. So I did a mistake in that angle calculation, that's all. Yeah, and in this question, this part is not actually correct. I mean, I know like they have given this as the answer. Even the other option also may not be coming, because the power given by heat source, that must be equal to the net heat emitted by it, which is sigma A into its own temperature power 4 minus K into sigma A into outside temperature power 4, right? But anyway, T naught power 4 minus T power 4, they didn't give in any of the option, so I didn't bother about it much. And in this question, yeah, so yeah, one student was asking me like, if it is 90 degrees, then this will be critical angle, and it will be critical angle, and it will be internally reflected back. Now if it is critical angle, and if this is critical angle, it won't be internally reflected back, it will be grazing the surface again, right? So anyway, what you can do is, you can go with the assumption what they have said in the question. So a light ray is sent and it will be refracted, partially it will be refracted, partially it will be reflected, but they are talking about only the refracted ray. Now here it will be partially refracted, partially reflected, they are talking about that reflected ray, like the rainbow formation, right? And yeah, this question I had a problem with while integrating, like how to do the integration of this one and this one, because the limits look same. So I try to refer some source and I try to put that solution there, but which seems like very bad integration. So I think I could have done this. I know like the field at this point and this point are same. So what I can do is, I can try to find the field here. So that's what I did. I have taken a ring. Which is making an angle theta and theta here. So yeah, so if this is theta and theta, then you can easily calculate this is going to be 2 theta, right? This is theta, this is theta, so this is 180 minus 2 theta, this is going to be 2 theta. So I have taken a ring and I have found the field here, and I try to integrate it. Now field because of the ring is going to be K into charge of the ring by this distance square into cos theta, right? K into charge of the ring by this distance square into cos theta. Now okay, all the things I know, right? I need to find this distance. Now what I did is, I have taken this thing, this is the right angle triangle, right? If this is 2r, then this length is going to be 2r cos theta. If this length is 2r cos theta, then this length is going to be 2r cos theta sin theta. So radius of this circle is going to be 2r cos theta sin theta. 2 pi r into thickness will give me the area, right? So sigma into area, right? So this is the charge, this is perimeter into thickness, this will give me the area. So this is going to be charge, K into charge by distance square into cos theta. I have to do the integration from where to where. When theta equal to 0, it is going to be this point. When this point is going to be theta equal to pi by 4, because this is r, this is r, so theta equals to pi by 4. When I do that integration, I am going to get this much. What is this? This is the field here or here. Now I know field here is going to be this direction. So if I apply Gauss law here, net field E2 into A naught plus E3 into A naught must be equal to total charge enclosed by epsilon naught, right? So E2 into A plus E3 into A equals to total charge enclosed by epsilon naught. From there I will be getting E3 value as this much. then I can take the ratio. I think this would have been the better integration. I was worried about like how to put the limits between these 2 points, but yeah, calculating here is going to be much easier. And yeah, this one I made a mistake, sorry. So the mistake I made is this part, right? Magnification. I have taken like height of the image is equals to minus 3/2 times of height of the object by default, but I didn't bother like v and u are changing, so I must not take this constant. That is the mistake I have taken, I have made. So there are 3 variables. When you differentiate it and when you substitute the values, you will be getting the required answer. So the mistake I made is v by u I have taken it as constant, which is not going to be constant, right? Thereafter, I think relative velocity thing, you will be getting the answer as 18 by 5, 9, and you can shift the frames and you can find the accelerations, right? This is like kinematics only, right? Yes. So yeah, and if there is any question which you need explanation, maybe you can text me, so that I mean in this paper, if you need one more time the explanation or the better explanation, you can text me, so that I will be covering it in the next discussion. And if you are a hostler, maybe you can take help of class teacher, but most probably I don't think that's needed. But if you want me to take it up, you can either text me in WhatsApp or yeah. So if it is possible, I will be clearing it in the WhatsApp itself, but if I think that's needed for everyone, I will be taking it in the next discussion. So I am planning this way, so in every discussion I will be covering up whatever extra things in the end of the session, like what I did today, right? Any suggestions will be welcome. Thank you.